Okay, so it's time to start the last panel of the day. Thank you very much for being so resistant and staying with us till the very end, because I think this is one of the highlights of the day, since we are confronting now the real life. And you already met most of my invitees in the panel, but you will still get from them insights and tips on how to prepare your next steps in your research and what to have in mind in order to be commercially and market attractive. So this is the, let's say, the main purpose of our panel today. It will be a very relaxed discussion. After the many coffees that we had, we will make it as relaxed as possible. Well, feel free also to contribute still on Slido, even if at the end maybe we will not have too much time to get your input. We will still look at it after the event. So I want to thank very much for taking up this challenge. It's not easy to be here exposed to a round of questions that are not necessarily related to your presentations, but to your lifetime experience, so to say. And let me introduce the panel today. So I'm having here next to me Guillermo Figueruelo from Hydrogen Europe Research, with another hat this time. Raul Gonzalez de la Fuente from the Spanish Association for Standardization. Vicente Vert from MATTECO, you all already have heard about his company. José Alfredo Lana from ENAGAS, also you have met him earlier. And Csaba JANÁKY from eChemicles. You heard already about several projects of their companies. But now we are not talking about projects, we are not talking about necessarily experience, but we want to see your vision about how are we standing with this hydrogen production and with the green hydrogen production. And I will start with Vicente, so you will have the floor first. And I want to ask you, from the materials perspective and from manufacturing perspective, what are the key readiness gaps between the laboratory scale and the industrial deployment, especially regarding electrodes and catalysis?
Well, thank you for being the first, and sorry for being the first. It's the two things. So from the materials perspective, as I said, the lack of standard size, I would say, or standard whatever. I'm taking the opportunity that you are here from the Standardization Association is a question that is really difficult for us, because we need to be flexible for filling or for fulfilling what each customer needs. So independent on the material that we're relying on catalysts, depending on how much we can produce, it depends on the customer, but also depending on the size, on the configuration. So the challenge, or what we are willing to have, is something like they need to be this size by this size and this thickness, this material, this whatever. So for us it would be easier, but it is not. So then we need to rely not only on how we can implement good processes for our products, but also how flexible they are. So then we need sometimes to make them bigger, make them to produce different shapes to cover all the rainbow. So the most challenge is to have the same material at the end, the same sizes, but we can do so.
Okay, thank you very much. We will hear about standardization very soon, but until then, no. Until then, I will look at Csaba from the industrial innovation viewpoint. What distinguishes the promising hydrogen technology from one that, well, is actually or could be actually energy infrastructure?
Well, I mean, I think it's difficult to have one single answer to this. What I would say is, always when we talk about adopting a new technology, then we are looking for those technologies which are not a nice to have but a must have technologies. And this can come from various angles, but a customer will not adopt a new technology if it's just a nice to have, because they are very happy with the existing ones. It works. It might have some drawbacks, but if there is no real trigger, whether it's a financial trigger, it's a regulatory trigger, but some kind of trigger, then there will be no change. So I really believe that the new technologies need to answer this challenge and need to be a must-have for the customer. And that's an important task for the technology developers, because they have a value proposition, they have an understanding why their technology is better than the others. But if they don't find those customers for who this is a must-have, then it will never be a technology. It will always remain in the lab. So I really believe that there must be a clear view which customers will look at our technology as a must-have, and those will be the adopters. If this is not going to happen, then there will be no technology.
Well, you're talking about the triggers, and I think it's also about the mission of the companies to define their end users, but also for the research is a challenge to very well identify who will be the one that will be the early adopter and the one to further uptake this.
Exactly, and this is a matter of timescales. So what we see is that large corporates face their immediate challenges. And innovators, especially in the academic communities, should tackle those challenges which need to be solved in 10 years, not now. Because if they want to solve those challenges, that's already too late. By the time it will be industrialized, there will be new challenges. So we really need to think about different time horizons, and those solutions and those challenges which are going to be the challenges for large corporates within 10 to 15 years. They are not yet articulated by most of the big companies. And that's why it's very important to engage in conversations early on and have those discussions to define really meaningful projects.
So it takes to be visionary, but in the same time to give time to research, to understand that this cannot happen overnight. But going from trigger to challenges, and I'm looking now at José, what is the hydrogen main challenge for today production technologies? Do you think that it's this production part, or rather the integration of the into the existing gas and energy infrastructure?
Well, personally, I think that at this moment we are in the moment of the chicken and egg dilemma. There are many technologies for producing hydrogen. The problem is that if we want to use renewable energy, that is the aim of the energy transition, is still expensive. For that reason, there are not consumption of hydrogen. So we need to solve this problem. I'm sure that technology should help to reduce the price of hydrogen, because the integration of the hydrogen in the value chains will be easy. At this moment, for instance, talking about infrastructure for transporting and distributing the hydrogen, as you see, there are not yet, although in the short mid-term will be available. My company is ready to build, and we hope that start next year to build the infrastructure. But for that, we need hydrogen on the production side and the consumption side.
Okay, so offer and demand in the
Yes.
end. And yes, for innovation is always the chicken and the egg. And I think the projects that are working on this are trying to break a bit the cycle. Looking now at Guillermo, because we are talking a lot of price, the cost all the time. But in the same time, from your experience working with industry and with companies, what are their needs and expectations today in relation to green hydrogen, and what type of support do they usually ask from your side?
Yeah, I would not talk only about green hydrogen, but also renewable hydrogen, which is now not the trend, but the taxonomy, I would say. And the key message is that companies want practical, the risk and cost competitive hydrogen solutions. And the main needs that we identified, or the requests that the industry is coming to us, is about the cost reduction, both in capex and opex, the reliability and durability. I've talked about that before, about the performance of the equipment, and to be operated and tested under real operational conditions. Also about the standardization and safety. We need clear, stable, coherent and harmonized rules not only in one member state, but harmonizing between all the member states and accelerating this implementation, because we all know how long has taken to arrive to these states at European level with the RED-free, and now the implementation that is lagging behind many, almost of the member states. And last but not least, I want to talk about talent and skills, because there is a strong demand for engineers, technicians, and operators. I would like to stop a little bit more here. I am in charge right now of developing our strategy lines as a region and as an entity, as Fundación Hidrógeno Aragón. We were pioneers in 2007 to develop our regional hydrogen roadmap, which is called Plan Director del Hidrógeno en Aragón, or Hydrogen Master Plan. We were the first region in the world to develop that. So I'm in charge of developing the new one, the new period, 2026-2030. And we are interviewing experts on hydrogen. Pepe, you will be interviewed next week. And one of the challenges and the strongest needs that we are identifying from the industrial is exactly this one, talent and skills. So I've mentioned a couple of them, but talent and skills I will put right now in the top one from the interviews that we are doing. And it is also kind of matched with the requested services that we develop. The highest volume or the highest number of contracts that we develop with the industry is training. Is training tailored training to companies, not only theoretical training but also practical in our facilities. These are small contracts, but are a high number of contracts. We used to perform in between 12 and 15, so more than one per month. And about 200 staff is being trained in our facilities or in our programs, which are kind of tailored to each entity. And also testing and validation, not only in electrolyzers, as I mentioned before in my speech, but also exposing components to hydrogen flow because of the issue of injecting hydrogen in a natural gas grid, or the repurposing in the hydrogen network. But not only these components and these pipelines, but also valves, metering devices, filters, and so on, and refueling of any type of hydrogen vehicle. We don't develop these vehicles, but you need to refuel your vehicle, and this is like the final step before going to pre-commercial stage. So these are like the three main services that we offer, and that were kind of reflected, I guess, in my speech before.
Thank you very much. And yes, training is following very much the research part. So first is research, then it naturally needs to come very quickly, the training. So everything that is generated becomes something very practical, but also this is happening a bit with the standards and certification. And I'm looking at Raul now. Guillermo already anticipated a bit, but in your view, how are the standards and certification at the moment supporting or otherwise constraining the hydrogen deployment?
Okay, for me, standardization and certification are not obstacles to hydrogen market innovation. In fact, they are precondition for bringing innovation to market in a sector like hydrogen, where we deal with flammability, storage, transport, interoperability. Trust is essential. Standardization gives us a common technical language, as are safety criteria, and a framework that allows technology to scale and to attract investment. Without standardization, we will only have isolated projects rather than a functioning market. Of course, there is a natural tension because technology evolves quickly in electrolyzers, in storage solutions, in new industrial applications, while standards need international coordination, need data, need consensus. But the reality is that if standardization comes too late, it may generate uncertainty and delay deployment. And the issue is not the existence of standards, but how and when they are developed. If we introduce a standardization at the end of the innovation cycle, it can act as a barrier. But if we introduce it early, it acts as an accelerator. For example, in other hand, if when we deal with sectors that implies significant safety implications, policymakers, investors are not very comfortable with committing capital or political backing when regulatory frameworks are not clear or are not stable. Therefore, maybe we can have all the technology prepared, but this doesn't guarantee deployment. Regulatory certainty is equally essential. Because of that, we need to have performance-based standards and certification schemes that evolves alongside innovation without compromise security. The goal is not to choose between standards or innovation. It's trying to align them from the beginning.
Well, actually, you will follow up, so you will be the one next. I think this is very important, and just before giving it to you back, Csaba, what I wanted to point out is that sometimes in EU projects, maybe we give not the proper attention to the regulatory analysis, to the standards, and to the certification part. Sometimes it looks like a transversal action, and not all the, let's say, academia and research community is giving the proper attention. So what you were saying is actually this needs to go a bit hand in hand and to anticipate the innovation. And yes, Csaba, please, if you want to follow up on this, and then the next question will be for you.
So I fully agree. So basically, for electrolyzers, it's a big problem that, for example, there is no standard accelerated stress test available. So there has been discussions for decades among the big players how to do it, but still there is no common protocol. And people project, okay, my stack will last 80,000 years, my stack will last 60,000 years, but based on what? And because you don't have a lot of parallel experiments running the stack for 10 years continuously, and different companies employ different accelerated stress test protocols, but there is no harmonized ones, and it's very difficult to get a common ground and understanding. And none of them is offering warranty, of course, for that lifetime. So they offer a warranty of 2 years, 3 years, max 4 years, but not, and predict 80,000 hours lifetime, which is not 2 or 3 years, obviously. So that's a huge problem, and I agree from the regulation perspective, it's pretty much there, but in terms of standardizing performance assessment, that's still missing after decades of electrolyzer development. So.
Let me complicate a bit the thing for you. So let's dive deeper into these barriers. So you mentioned a lot standardization, certification, but what do you see, where do you see the biggest friction today? So let's take on the one hand certification and standardization, but on the other, let's talk about technology performance, system complexity, costs, and even customer risk perception. So from out of these, let's say, how many? 5? Which one do you think it's the biggest one?
Well, I think it depends on the situation, but what I would pick one to discuss for this particular audience, I think the system complexity is one thing what we often neglect. So we develop one system component as an R&D community, and then consider that all the remaining parts will be off-the-shelf components, and then the system can be built. And this might not be true, because if it's a new application or a new type of application for those other balance of plant components, they might not work as planned in that given application. Let me tell you, this is not a hydrogen example, but I think we can relate to that. So for us, we in CO production, similar electrolyzer technology, we consider that there are a lot of off-the-shelf components coming from the hydrogen industry, let's say, which we can use in our technology. And it turned out that it's not the case. So we purchased the equipment and they failed because simply it was a different gas mixture, it was a different media, it was a different chemical environment, and they didn't work. They didn't fail in a way that they did work. There was a signal, they showed something, but that signal was not correct. And I think this is more general for any kind of new technology, that let's say we are developing the core technological component and then consider, okay, all the rest can be purchased and then we just integrate and it's going to be fine. But very often the case is that also the balance of plant components need to be systematically screened and identify which are the ones which will work. Just to tell a very simple example, flow meters. To find proper flow meters for mixtures of hydrogen, CO2, even if there is some humidity in addition, good luck. So we have tried all the different kinds, and then we use two different technologies, and with the combination we can get something which is more or less acceptable. But this is something trivial, so one would think that gas flow measurement is not rocket science. And I could tell a lot more examples when assuming that there is something available is a wrong assumption.
Well, I think this gives a lot of room for investigation, and I think that a lot of people in the room are happy to know that there are still a lot of things to be done. Going to Vicente now and going back a bit to the materials, how critical are the raw materials availability and the critical raw materials constraints when we talk about hydrogen technology and scale up?
Let me ask this question after for continuing the discussion that we had before. Sorry.
Okay, if you don't need me, I can go.
No. I mean, it's critical as well, but it's a question that, of course, when we are saying that the stack can rely 8,000 hours or whatever, also we need to rely, as we are component providers, we have not neither those standards to say, okay, our material works like that in that condition, so it is okay for you. And as I said before, flexibility is quite difficult. Against, we need to not only fabricate things, but also test things against each customer systems, ASTs or whatever protocol. So it's quite difficult to really trigger that. And it's not always on the balance of plant, but also even inside the things that are several things. So that's so short. The rest, of course, about materials, yeah, it's a question that it's, I mean, we're discussing on the lunch or whatever. I don't know what to happen next year about the world, because it's something like what will happen. But also regarding materials, the same. But as far as we are just looking here, every component is based on nickel. Every component, irrespective if it is for HER or GOER or OER. So, and we realize that nickel is okay, it's not a critical material, but now in Europe it's something like a strategical material. So it means that, hey, could happen. And when it happens, I mean, let me say that if nickel is say, okay, it's a critical raw material, and we are making things CRM-free, and we're relying on nickel, oh, what to do? It's a one thing. And the second thing regarding nickel, it's a question that we have really concerns on that. It's safety. Nickel itself and nickel derivatives, I mean, I'm not really happy to have on the table as a dust. So we implement within our facilities a really good air renovations. We are just wearing something less masks and 2 or 3 folds of protective things for that. And it's really costly, but we need to trust on that for the employers that we have. So it's 2 folds of of course, scarcity, of course, or things that, and then we can just discuss our recyclability and where this nickel comes from, maybe, or nickel cobalt that we were hearing today. But also, cobalt has the same problem about safety, personal safety. So it's not only because of that, but let's think about that. And once there is something, let's say, hey, you're not going to use this nickel, the same happening for PEM, I would say, with this Nafion, based on fluor. Hey, what happens next?
Well, thank you very much, and I'm really happy that, especially coming from a company, you are talking about costs that are not necessarily financial, but are also translated in other type of costs, like safety, like health, like the well-being of the employees. So I think this is also very important to consider when we are talking about the costs. I'm going now again to José. I know that you talked about offer and demand, but since you deal a lot with infrastructure, we are going back to the infrastructure part. And what do you think that technology developers should focus mainly on when it comes to infrastructure and system level constraints?
Well, talking about the pipeline system, that is my knowledge. We are going to build, I think most of the pieces needed for building the network are ready, but because mainly, hydrogen is not a newcomer, as I said before, is more than 100 years in the industry, but was in the industry in a different scale and for a different purpose than nowadays. If we want to move gas from A to B, perhaps separated 2,000 kilometers, we need something that is not ready, or is not almost ready at this moment in the industry. For instance, gas compressors. Of course, there are a lot of compressors for hydrogen. We have the hydrogen refueling station that needs 700 bar, so there are very big compressors. But for a hydrogen refueling station, perhaps you are going to compress, I don't know, 100 kilos per hour of hydrogen. We need to compress perhaps 20,000 kilos of hydrogen per hour. Perhaps not to a 700 bar, but only a delta of 10, 15 bars. But for that, alternative piston compressor is not as efficient like a centrifugal compressor that is the case of natural gas. So there are some pieces of equipment that need additional development. For pipeline, okay, we know how to deal with the pipelines, but perhaps not all the manufacturers, traditional manufacturers for natural gas industry are ready for hydrogen. Will be, but they are not all ready. But in any case, that means more cost, and other issues that we can deal with that. And another problem is related perhaps to certification and normalization. You mentioned metering. Well, metering of hydrogen, the technology is there. All the flow meter manufacturers know how to measure with very high accuracy the hydrogen. But the problem at this moment in Europe is the certification. There are not any laboratory ready to certificate a pure hydrogen flow meter, because we are building laboratories, but they are not still ready. So everything is there, but we need to some fine-tune in the next coming years that I'm sure we will ready for that.
Well, thank you very much to all of you. You are making my life very, very easy here, because you are actually helping me to have a nice flow of discussion, because you talked about standardization and Raul was next to answer. So yes, we are having this fast-moving development, but in the same time, apparently we are having slow standardization, so slow process standardization. How can we do it to bridge this gap and to ensure that somehow these are aligned, like you were saying in the beginning?
For me, the main gap is temporal, because technologies are advancing faster than harmonized standards and harmonized standards can be developed. We can see rapid innovation in electrolyzers, in storage systems, in industrial applications. But as I said before, standardization requires consensus, requires international cooperation, requires mature technology, and that takes time. And this gap creates three types of risk. Firstly, safety and technical risk, because when we don't have common references, each project can apply their own safety levels and their own technical criteria. Secondly, we have a market risk, because regulatory uncertainty discourages investment and complicates financial decisions. And finally, we have a risk related to fragmentation, because if every country develop their own national or ad hoc solution, later harmonization is going to be much more complex and costly, and reducing competitive. However, this gap is not inherently negative, because it can be a space for learning, pilot projects, regulatory sandboxes, prenormative technical specifications can bridge innovation and formal standardization. For me, the problem is not that this gap exists. The main problem is failing to manage it in a coordinated way between industry, regulators, and standardization bodies.
Okay, thank you very much. But for all this, for managing in a coordinating way, for sandboxing, for pilot projects, we need money. And I'm looking at Guillermo. How are the EU funds and policy even supporting the scale up, the innovation per se? Or do you think that this, all these funds are mostly destined to the technology readiness than the scale up and preparing for market?
Yeah, so the answer is quite complex, as well as it is to fund in an agnostic way from public funding, from the European Commission, from national funds to many technologies, or in an agnostic way to any technology at all. So, and I think it was really explained from your perspective. So the TRL, the UE instruments still lean too much isolated TRL progression rather than full value chain deployment. But how can we attach or match everything? I think we have been tackling really much on the production, and I wanted to give also the message to be funding also the demand. I think we can come back later to that. But what industry needs is a bankable business model, predictable energy prices, again with regulation, stable but also predictable regulation, and this is really complex to match at the same time with funding. We have developed, for instance, for the hydrogen sector, or for the clean hydrogen partnership in particular, or for any joint undertaking, you have been drafting an SRIA, a Strategic and Research Innovation Agenda, by 2020, more or less. There was indeed a midterm revision in 2023-2024. But the industry goes on on another rhythm, while the European funding are sometimes burning from nowhere, or the people don't know from where it comes. It happened with the next generation. Suddenly we have billions of euros there, and it has been really, really complex, not only to know where to spend them, but also to execute these funds. We are about 4 or 5 months now to finish the execution deadline, and there are still millions of euros, even not hundreds of millions of euros, only in Spain to be executed. And something similar happened with the Repower EU. So it's really complex. I think that conversation have already started about the next framework program 10 in Europe. They again want to go to a simpler methodology and so on. But I'm not quite old, so I have only lived FP8 and 9, and now I'm willing to live or to experience FP10. I see that things are kind of more simple at European level rather than in national funds, but making things more simple at the same time than matching the industry needs, the TRL methodologies and so on is quite complex. And I think, well, we are humans and we cannot be, maybe with artificial intelligence we solve the problem. So I think more or less I have answered your question, and I didn't want to open this bracket before, but with regard to the protocols, we have the JRC harmonized protocols for low temperature electrolysis already settled down in 2021, and for the high temperature electrolysis in 2024, I guess. So we are offering these protocols to our industry stakeholders, and the European Commission is asking for these protocols to apply for their funds. Maybe I'm living in this bubble. Is it not worthy, these protocols?
No one is using that.
It's absolutely worth, but the NREL has a different protocol in the United States. In China, they have a different protocol. So up to the point, it's not a globally accepted protocol. I'm not saying it's useless, but almost. Because there is no mandate for the companies to follow it. And that's the big problem. And it's very good that we have something, but even it's not a formal European protocol that it has to be followed. Of course, Commission can encourage companies to follow it, but until it's not mandatory, that's the problem. So for solar, for example, it's very clear. If somebody wants to develop a solar cell, nobody considers it to be serious before it's sent to NREL in the United States, and they analyze it based on their standard protocol, and they put on the chart that, okay, X company can get this power conversion efficiency. And everybody knows globally that without being on the NREL chart, you are out of business. Even Chinese companies go to NREL. And that's something we really miss for electrolyzers, to have one golden standard, what is accepted by everybody. But I think these are the seeds, what you have, but somehow this should, grow further.
Yes, and sorry, and maybe it's a question not because they are useful or not, because each company is making, as I said before, their own war. I will say they are developing themselves and say, okay, I will not touch on that because I will go in that direction. But this is not the same as the other direction, coupling with renewables, which renewables we are using, which are the profiles, whatever, and somehow. And then, since there is not any, I will say maybe it's another bubble, I will say, it's something that is not clear, each company is not really clear what they really want in 10 years, they cannot trust on this kind of protocols because they are not aligned what they are thinking that maybe in 10 years is happening. So it's a question that we are also, I would say, blind and say, okay, we are following that. And the people say, okay, it's okay, but I need mine to be tested against. So it is a question that needs, it's a good as a seed, but maybe we need to, go further and to find a more broader solution for that.
So this emerged like an ad hoc topic of the panel. This is a living panel that, very nice. And I hope that you will continue during the networking cocktail that we are having afterwards, because I see that there are other examples and ideas that maybe will follow the same path. But since we got to the forward-looking, let's say, steps that also will help projects like OHPERA that are coming to an end to think about the next road to take and how to continue, where to put their efforts and their attention. I will start with you, Vicente, because you have the microphone. What should they prioritize first? The performance gains, the cost reduction, the material sustainability, something else, and why?
Maybe I have not the answer because from our point of view as a company, we are trying to get the best benefit and the best profit. But once we are asking to the customers, they say, okay, let me try this off-the-shelf material you have, then try if its performance is okay, then start with my own protocol to say they need to pass this kind of test, and afterwards, and after that, it's cost. And then ourselves, we are making sustainability by ourselves, but also thinking on cost, I will say. It's a pity, I will say, regarding sustainability. But as I said on the other answer is, well, once we have a problem with this supply, whatever, maybe circularity, it's starting getting that on safety. And then you need to add these values. You can monetize this as an environmental impact can be monetized, but also you can put in the other way around. So maybe it's at that point. But the short answer is first performance, then cost, then sustainability of materials.
So we have a clear roadmap here. next things to do. And Csaba, in terms of practical design and development choice, what will projects like OHPERA also do to improve their chances for market uptake?
Well, I will follow up on the previous point. So the performance first, which means that even at early stage development, I mean, maybe not at the very, very early stage, but further down the road, we need to identify whether there are available components for a given technology to scale it up. Because it's also not trivial. So one might think that, oh, I will have the necessary size of porous transport layers or gas diffusion layers, but it's not necessarily true. So it's quite important to have a scale-up roadmap and identify what kind of challenges might arise during that scale-up roadmap. And that's exactly what we are doing actually in OHPERA now within one of the final deliverables to analyze. So we envision a pathway, how this could be brought forward, and we identify what kind of bottlenecks can come or what kind of roadblocks we might anticipate in terms of suppliers, for example, and things like that. So I really believe that even if we are early on, we need to look ahead also, not just at the immediate next step, but try to envision what will be the challenge or what kind of challenges we envision once scaling it up to the actual scale, and whether those challenges are solvable or they are inherent, or that they might be inherent to the technology. And that means that it's not scalable by definition. And that's something we have to study early on, because in that case there is no point scaling it further.
And Raul, in terms of standardization, what should research and development projects do in early stages to avoid late bottlenecks?
Okay, the most important shift is conceptual, because standardization shouldn't be seen as the final administrative step before commercialize, but as a part of the innovation strategy. At early R&D stages, researchers and developers should understand which standards already exist, which standards are under development, and which safety, technical, and interoperability requirements may apply in the future. And this involves 3 concrete actions. Firstly, engage early with standardization bodies, even while the technology is still evolving. Secondly, it's important to try to design with the marketing integration in mind. That means performance-based approaches and avoid very close solutions that later they are going to be very difficult to standardize. And finally, it's very important to participate actively in technical committees. No one understand a new technology better than its developers. If innovators are not present when standards are drafting, others will decide the frameworks for them. Pilot projects should also be viewed as evidence generators for future standards. Operational data, failure modes, performance results are essential for robust normative framework. At UNE, we are increasingly participating in R&D projects. European authorities have recognized standardization as a strategic tool for competitiveness. But, however, there remains a structural distance between research community and standardization ecosystem. And the reality is that when we are able to integrate standardization from the beginning, it becomes a competitive advantage rather than a bottleneck.
Thank you very much, and I will use what you have just said now to connect with what Guillermo said earlier about the money, that sometimes we don't understand why a lot of money are going to certain directions. Of course, we all know that it's a political decision behind, but apart from that, sometimes it's a decision based on the ones that were at the table discussing. And if we don't make sure that the good ones and the expert ones and the ones that really can provide good insights and good data, if they are not there, then the decision will not be the best one. And we will end up dealing with situations like this as well. This is something that is happening for a lot of call of evidence or call of contributions that European Commission is doing for a lot of even work programs, but also regulatory framework and so on. And most of the time, academia and researchers are not very active there because they consider they have other forums, but sometimes the decisions are based by the contributions that are there. And there is this kind of disconnection, and sometimes we end up having not the proper framework, and then we are complaining that it doesn't fit what we are doing. But of course, it's also difficult to follow all this. But being visionaries, and because we are talking now about really looking forward and trying to imagine how the future would look like. José, if you consider yourself in 2030 now, what type of hydrogen projects do you think will survive and will be scaled up? The large ones or the local production ones?
Well, I think if you remember my presentation, you can imagine the answer. I think that the projects in the future with the large production sites that will need a pipeline to transport the hydrogen from the production site to the consumer one, the big industries, refineries, fertilizer, hard-to-abate industries, etc. Anyway, saying this, I'm sure that there is a space for everybody. We are going to change the energy paradigm. We are going to an energy transition, carbon-free, net zero, etc. For that, we will need a lot of hydrogen. So I'm sure that there are a space for local production of hydrogen, for technologies that like the one that we have seen here, that will have his piece of the market. Higher, lower, you know. I don't know, but I'm sure that always the cost-benefit analysis will be there for some applications. So for me, there are room for all the type of application, and I think that if we want to move to an hydrogen economy, we need large production site and distributing production site.
Thank you. And closing this round with Guillermo, what do you think Europe should prioritize in order to make green hydrogen a real business option?
Yeah, again, renewable hydrogen, I will highlight, and this is, I mean, we need to change somehow our mind. Yeah, coming here today, I recall that I was in your position moderating a panel in Zaragoza in Red Hydrogen exactly 4 years ago. I remember because when I was on my trip there, on the radio they were saying that the war in Ukraine and between Russia has just started, and today they were talking about it is today the 4th anniversary, and I was already asking to my panelists, what do you foresee to do during this decade to be able to achieve the goals by 2030. So what has been answered there, I don't recall it, but maybe we have time. Anything that we do right now today or we start right now in 2026 will not be ready for 2030. But we develop, Europe developed a strategy in 2020. The goals were really ambitious. We are not going to achieve them by far. I don't mind because the market is being creative, and you need to be at that level to at least reach a medium level. But maybe the focus was not the right one, because, and I think this is a common knowledge or a common opinion, we were really pursuing the electrolyzer manufacturers, or ramping up through gigafactories the production. We see right now that we have spent, the Europeans, many millions of euros that went to OEMs that are right now on bankrupt. We have the clear example of McPhee. Okay, John Cockerill or ThyssenKrupp have bought the IP or the assets from these entities, and the market will continue somehow rolling. But we received like 2 weeks ago the pieces of news that Cummins is somehow closing the hydrogen business and the factory in Guadalajara here in Spain. So now I think the focus is more on creating the demand, and I don't want to repeat much more about what I was mentioning before, but the permitting affordable renewable electricity, invest in skills and workforce, but the clear milestone for being able to create this business option, as you were asking, is creating the real hydrogen demand. How? This is also a complex question to be solved, because we are working with contracts for difference, with carbon pricing. We are putting money on the table through the hydrogen bank with this auction that is not well functioning, because we see that are more projects that have declined the money that accept it. And maybe one of the options, but this is also a really complex pathway, is through hydrogen valleys. I don't need to explain what is a hydrogen valley, because I'm relying on your attention on the presentation on Julia Machado, but we are connecting there somehow the alignment of the regional ecosystems with the large demonstration hubs in which production, distribution, consumption, but also the civil society and the public bodies are coming together.
Well, we are having this panel recorded, so maybe in 4 years we will remember what we have said now. And while I'm giving you a bit of time to think about the single most important action needed to unlock hydrogen market production, which will be the rapid fire ending question of this panel. So the thing that we will keep in mind when stepping out of this room, so the first step to take to unlock hydrogen market production. I have a question for the audience. I will not let you sleep. So if my colleagues can put on the screen again the Slido, so you can scan it, or if you have it already on your phone, we can already answer to the question, what would motivate you to combine hydrogen technologies with other industrial processes? So now step into the shoes of the industry. Imagine that you get to take this, this decision. So based on what you will decide to combine hydrogen with other industrial processes. What will make you say, yes, I do? So while they are answering, let's go through our single most important action. You have answered to most of my question with, this is a complex situation. So now let's putting it simple. The single, not simple, but the single most important action to be done in order to unlock the hydrogen production.
Have a simplified and less dogmatic regulatory environment.
Okay. Next.
Yeah, highlighting again that we need high cost-effective electrolyzers and production, but it is more important to foster, to create this demand so investors in the industry can go for and put the money on the table.
Okay. Vicente?
Okay. I need to agree. It's a question, and once the demand is here, that it's demanding, what is the blocker? Cost? I mean, it's electricity, then find electricity cheaper. It is the leverage cost of hydrogen or availability. But at the end, is once there is a need, I think the technology is almost ready for that.
Okay.
For me, the most important action is to align technology, regulation, and standardization now, providing market certainty.
Besides to all these things highlighted by my colleagues, I think for me the most important is the companies' compromise with the production and consumption and construction of infrastructure related to hydrogen. We need that the companies take the final investment decision as soon as possible to allow the market to be developed.
Okay, so it's mostly market, it's mostly regulatory, and the demand in the end. Okay, thank you very much. Our audience is going to the economic benefits and cost saving, very pragmatic, very decided, but again, new revenue streams, it's again related to economic benefits, and somehow also important decarbonization targets, but thanks God they made it in top 3. But yes, it's clear that it's all related to cost and economics. Well, thank you very much. Thank you very much, dear panelists. You have made it very easy. I think we had a very, very nice discussion with an ad hoc topic, so quite good to start our end of the meeting. And I will let you continue the discussion during the cocktail. We are having also some questions. Wow, surprise. When we ask for questions, you didn't have any. Now we don't ask, and you have. Okay, very flexible in our meeting. So for you, José, how the steel embrittlement issue in the pipes is solved?
Well, the behavior of hydrogen and steel is already known. It's very well understood by the industry and by the manufacturers of steel. So the issue is to the proper selection of material. We know that we cannot use any steel with hydrogen, the proper selection, and also the proper selection of the operational conditions. If you select right the material and you operate your pipeline under certain conditions that are not very difficult to fulfill, of course, there is no problem at all with embrittlement. In fact, I know that in Germany they carry out a study and conclude that if you fulfill some limitation, not very hard, including pipelines built in the 30s can be used for hydrogen. 1930s.
Okay, promising, I think. And we are having another one. You let me know who wants to take it. If flow and high temperature electrolysis are the future, what will drive them with input energy, or must they use existing renewable resources?
Yeah, I'm not sure if I understand what will drive them with, with RED3, you need to comply with the additionality, so you cannot use existing renewable resources. You need to install a new PV plant or a new wind or whatever renewable installation. At more or less at the same time. I think the time is 3 years, no more than 3 years before the starting of the hydrogen production, and therefore we have also the temporal correlation that is becoming harder with different milestones, hour, quarterly, and even at minute correlation. So I don't know if you cannot use existing renewable sources. Yeah, that would be like the final answer. But with the beginning of the question, what will drive them with input energy? Yeah, I don't get it.
Okay, thank you very much, and I will thank all the panelists. I think that now we can release you, and again, thank you for the challenge to answer all the questions and being here in the line of fire. Yes, they deserve a wealthy applause. And now it's time to come close to the end. I think I can use this other one. Okay, so it has been an intensive day. We have discussed about a lot of things. I hope that you mostly will remember everything. Otherwise, we will have a small report for you that will come at a later stage when we will be able to process everything that we went through today. Before seeing the amazing graphic that Fanny was drawing all day, I have more questions for you. You didn't deserve yet the networking cocktail. So we are going back to Slido, and I would like very much to know in one word, this time similar to what I've asked our speakers, what needs to change first in order to enable what's a widespread hydrogen market adoption? So think, well, in one word is complicated, but in the same time simplifies a lot the situation. And if you can simplify it, it means that you know it very well and you have it clear in your mind. So let's hear from your side. What do you think will be the thing that needs to change first to enable widespread hydrogen market adoption? So demand apparently goes first. So our panel had a great influence on the audience, or you are perfectly aligned. And then cost, a huge cost that we are having here. Infrastructure, also some efficiency, policies, scaling up, the environment, small there but exists, perfect. Synergies. I hope that you will you manage already some, and you can still continue during the dinner. Regulation, security. Okay, so quite some things to do to enable this market adoption. And trust, I like this one. We need to trust each other in order to be able to do everything else. Demand, integration, costs, synergies, environment. Environment has is a bit bigger. I like it. Thank you very much for the ones that voted for the environment. And I also am curious about how today's workshop has changed your perception on solar-driven and, I will not say green, renewable hydrogen in this case. So we can go to the next question. Let's see if after everything that happened during the day you feel more positive about it, not so positive, or not sure, or no change. I hope no change, because you already came very decided from home, not necessarily that our day was not productive. Okay, so slightly more positive. Okay, so a bit going to the right direction, because we really hope that you will be positive about it. Believers, yes. If we are in the room, I really hope that we are believers, and that we trust that this can be a positive change. Okay, thank you very much. And now the most waited moment of the day. Fanny, please join me, and let's see how your visual graph look like. Don't expect technical things. If so far we had a lot of terms and a lot of technologies explains, a lot of formulas, graphs, and so on. Now we will have some very simplified summary of what we discussed today. Let's see if the tech is working. Fanny, please, yes, explain us.
Thank you. Thank you and good afternoon. I'm usually more comfortable behind my desk drawing, but I'm gonna play this exercise of explaining a bit what I've been doing all day. It was a pleasure to be listening to all this amazing session. So my name is Fanny Didou. I'm a graphic recorder. So I was here to capture the essence of the conversation and also capture what's touched me and what I found interesting in another visual way. So I take you for a little visual journey. So first, in the morning, Mihaela, Evelina from the amazing Lomatov team opened the floor, set the ambition, scaling up circular innovation in Europe. We had in the morning a European perspective from Johannes online. And yes, Europe is incredibly strong at scientific research, but we are still struggling to consistently turn scientific excellence into commercially successful, scalable businesses. And this is exactly what today was about, from research to market adoption. Here you can see the session 1. We got into the topic, exploring OHPERA concept, the target environmental impact reduction, efficiency, profitability. Here a little wink to the Slido. Now the challenge is cost competitiveness. Session 2. It actually helped us to take some perspective and look at it in a more systemic way. And renewable hydrogen is not about one technology. It's about this ecosystem of interconnected solutions. And yes, we talked about economic impact. We talked about environmental performance. And I was very happy to hear also some social aspects. Social acceptance mentioned, because yes, this transition is technological, but also it must be grounded, it must be accepted, and it must serve society and future generation. And we are going to session 3 here, time to scale. From atoms to industry. Yes, a lot of challenges, market uncertainty, high technological uncertainty, risk. How can we do a roadmap? That was from the last panel here, I read now. How can we do? We know one key idea, collaborating to accelerate Europe's decarbonization transition. That was from Blanca's presentation. Here you can see this network of the diversity of stakeholders involved, institutions such as the European Commission, universities, technology developers, consultancy companies, supporting SMEs. We go to session 4 here. From scale to reality, we reached industry and got some inspiration from our 3 presentations from the industry, dedicated to reduce environmental impact in a profitable way. From the production, but also to the consumption. What if we create the first major hydrogen corridor? Which brings us to our last panel here, unlocking market adoption, the value chain in dialogue. We need talents and skills, aligning standards and innovation, performance, sustainability, cost. I put it as a circle. And yes, to move from research to the market adoption, we need to work together, connecting the industry and research, academia, connect, create community, and such as this event coming together in Valencia to meet each other and to have later a nice cocktail. Thank you for attention.
Thank you very much, Fanny. So everything translated in lay language and visual and colors and dots and connection and graphs. So this is somehow what people understand from what we communicate. And this is what they retain, the things that they can relate to, the things that are connected to their lives, to that they are impacting them as a community, as a society. So apart from all the outcomes, the technological outcomes, apart from all the challenges that you want to solve, I think here there are some key aspects that you need to consider in order also to motivate yourself each time you are going into your labs or into your offices and you start working on this, because there are good days, there are hard days, but in the end, this is why you do it, this is why we do it. And in order to close the day, we have started with Sixto, we have started with OHPERA and with him as coordinator. Now, if you want to give us a few words, a few final words and your, let's say, feeling after all this day, please come join me and let's hear if our coordinator is happy with what we have done during the day. And if you are happy or not, you will tell us through the evaluation survey. You have the last QR code to scan, I promise. Sixto?
Yeah, thank you. Thank you very much, Mihaela. Yeah, thank you very much, the Lomartov team, for the really wonderful day and the opportunity to interact with all of us, and thank you very much also for all the panelists and the attendees. So I think it was a really wonderful day. We all, I think, we learned a lot from each other. So just enjoy the cocktail, and thank you very much. I hope you had a great day. Thank you.
We thank you all for staying until the very, very end. We thank you for taking the time to come to Valencia from close or from far. And we thank you, the ones online, for following us or looking at the recordings afterwards. And yes, now it's time to close, to be happy and to enjoy our dinner. Yes, José, sorry, we don't close, but it's not my fault. Yes.
The evaluations or no is working, but I have a doubt. 1 is the best or 5 is the best?
5 is the best.
5 is the best. Okay, thank you.
Cool. If you score more, you get more points. Okay. Okay, so 5 is the best. Just this mention also for the onlines. And now we really close and we really go outside to enjoy the cocktail dinner. Thank you all.